slice at a time. But as of now, we have seen what are those 3 slices? EMPP, URLC, MLPC. Correct. Okay. So next, which network element is mainly used for this network slice? NSS. What is NSSL?
Network
Slicing Selection Function. Right. So inside this NSSF, you have one more network element. What is that? NSSAI. Assistant Informations. Okay. Right. So last class we have seen how your user equipment is registered. Okay. From UE to your core network, and where the function NSSL works. Okay. Then you got that you have initial AMF and target AMF. So with this, it will reach back to the user equipment. Right. So how many planes is there in the 5G core architecture? 2 planes. One is control plane, another one is user. So control plane, which is used to establish a connection, user plane, which is used to transfer a data from user equipment to your external network. Right? Okay. So now you have seen what is slices. Correct? Okay. The next unit we are going to focus on each slice. Okay. How many QoS will be there? That is your quality of service. QoS. Right. So how many QoS will be there? Last class one, but last slide. Maximum 15 PDU sessions. PDU session is 8 slices and PDU session is 15. But QoS is different. Okay. Based on the number of requirements, there is no maximum and minimum count, especially for your QoS service. Right. Okay. Now, what is actually PDU? Protocol data unit. When this PDU session is created? When this PDU session is created?
When a user requests
Whenever your connection is established with the control plane, then your packet has started transmitting your data. So that time your PDU session is established. Your PDU session is nothing but it's a channel to transfer your packets from UE to the external network. Right. Now we will see about what is quality of service. Okay. And what is quality of service, which is involved in 4G, and what is advancement we have done in 5G. First we will see this, then we will discuss about detail. Okay. So QoS unit means nothing but which is your data bearer. Data bearer means it's a bridge. Okay, it's not a bridge. It's like any vehicle. Just imagine it's a lorry. Okay, this lorry will carry your packets from your user equipment directly to the external network. Right. So in 4G, we can call this as GPS bearer, and 5G is your QoS. Okay, and identifier here, this is called as QCI and 5QI. What is identifier? Identifier is nothing but, suppose you have 5 QoS. Okay, one is for voice, one is for data, one is for live video stream. Okay, so how will you differentiate these 5? By using ID. Okay, that ID we can call it as QCI. Quality Channel Identifier in 4G. 5QI is your 5 represents your 5G. Q is your quality identifier. That means if suppose if I want to send one packet, that packet is your voice call. Okay, your QoS 1 will be identified. So what is it meaning? So one is identified and one will be sent from your user equipment. Next, suppose if I am giving I value as 2. Okay, I value is 2 means automatically your data will be your internet data. Okay, will be focused. If it is 3 means your live video stream will be focused. So that represents wavelength. That wavelength is comes under F2, sorry, 5Q. So 5 is your 5G, Q is your quality, I is your identifier. Right. Okay. So here flexibility is one bearer, one separate. Okay, so here multiple QoS flow per PDU session. Just imagine. So this is your PDU session, correct? So you can see how many slices it is given here. This is for example. 1, 2, 3, 4, 5, 6, 7. So 7 QoS will be given. Okay, so this is in 5G, correct? But in case of 4G, you have only one parallel services. So that means I can use only one QoS services in the PDU session at a time. But when I go to 5G, I can use 7 QoS flows within a PDU session at a time. So that is the advancement from 4G to 5G. So that means I can differentiate different number of quality of services based on the user needs. I can give one is for voice, one is for data, one is for video at a time. I can handle in 5G. But in 4G, you can handle either it is live video streaming needs, only that particular part will be handled. Either it is voice data needs, only that part will be handled in the video system. That is a major difference in 4G versus 5G. This table is mainly based on QoS services. Right. So next is services your primarily broadband services. So far you have seen that broadband services, correct? Evolved from your coaxial cable, fiber optic cable. Now it's 4G, it's 5G. That broadband services. But here the slicing takes part. Your EMBT services, URLC, MOTC services, right? And latency you see here 10 milliseconds. Here it is as low as 1 millisecond. So that is the main difference. Why? Because I am providing QoS, made multiple QoS within a single PDU session, so that my latency also gets reduced. What happens here is, first it goes for voice call, then once your voice call is transferred, then it will transfer your data, then your video streaming, so it will take time to reach. So your time delay also 10 milliseconds for your 4G. Here it is 1 milliseconds. Right? And next customization is limited. Here, network slicing dynamic QoS is there. Okay, so what does it mean? Customization means I cannot do any modification. Okay, there is limited modifications can be done. But in case of 5G, if I want to add any QoS, extra QoS in the same PDU session, I can do. If I want to remove any QoS session already present in this PDU, I can do. So that kind of customization will be done in 5G. That is not in 4G. So once your PDU session and your QoS is fixed in 4G, that will not be changed. So that is limited. Right? So here the name itself is shown. Dynamic means I can change based on the customer needs. Okay. Okay. So I think last class itself I showed, right? Okay, fine. User equipment, your data. Okay. So forget about your control plane here. Right? So which plane is involved here? Only user plane is involved. Okay, because we are focusing on quality of service. If you are focusing on quality of service, only user plane is involved. Okay, why? Because SMF will give the instruction to the UPF to create a PDU session. Correct? Once your call is established. Right? So once your PDU session is created, in this PDU session your QoS has to be established. Correct? So that they are not focusing on which part? Control plane part, they are focusing on user plane part. Right? So what happened is, this is your user equipment. Okay, so up to this part, your connection is established. Now I'm going to start transferring the data. Right? So what happened? You see here, user equipment, this PDU session and data network. Who will create this PDU session? Which network element is enabled to create this PDU session? Which network element is involved in this PDU session? Or which is there in the user plane? UPF. Correct? Because the only one network element which is present in the user plane is your UPF. So, who will give instruction to UPF? Who will give instruction to UPF to create a session? Yes. SMF. From SMF, who will give command? This network element is commanding SMF to create AMF, which is used for initial registration, that is access mobility only. PCF, policy control function, will instruct the SMF. Okay, the SMF, what policy control function will do is based on the customer needs. Okay, I told you right, any tariff kind of thing that will be given by PCF. If any network slicing to be happened, that instruction which is coming from NSSF, that will give to PCF. PCF will instruct the SMF. SMF finally instruct the UTF to create a video session. Correct? Okay. So once your video session is created, okay, so you can see it provides differing dual characteristics based on latency and data rate, warranty or non-warranty. Okay, so in this you have to know the names GBR and non-GBR. Okay, so GBR is nothing but your warranty bit rate, non-GBR is nothing but your non-warranty bit rate. Any idea you have on what is about GBR, which comes under GBR, which comes under non-GBR? Suppose I don't want to get disconnected from the connection because I am doing live streaming or any live audio conferencing, right? So that what I need, the guaranteed bit rate. Guaranteed bit rate means, suppose if I am giving for 50 Mbps, say for example 100 Mbps, which is flown from your user to the external, right? The same 100 Mbps will be maintained till the end of the session. Correct? So that is guaranteed, right? So guaranteed amount of data rate should be flow till the end of the session. That will be provided. That will be called as your GDR. That is your guaranteed bit rate. Non-guaranteed bit rate is nothing but whenever I need this much of data rate, that time this will be allotted. This data rate will be allotted based on the customer needs. Any example? Any example for non-GBR? GBR I gave an example. I don't want to get disconnected from the connection, so I need a constant data rate to flow from user equipment to the external network. Also, one example for guaranteed bit rate is your voice call. Correct? Your voice call, you don't want to get disconnected while talking simultaneously, right? So that needs your guaranteed bit rate. Non-guaranteed bit rate is nothing but one best example is surfing data. Whenever you going for Google, okay, so you're typing Google, that time you need data. That time you need not data, your bandwidth. Correct? Then rest of the day you don't know. Correct? So I don't want to give a constant data rate or constant bandwidth to a particular session. Correct? So that will come under non-GBR case. Right? Okay, so constant bit rate to be transmitted means you need GBR. And if I don't want the constant, so whenever I surf the data, I need non-GBR data. So that is the difference of GBR and non-GBR. That is nothing but your warranty bit rate and non-warranty bit rate. Right? So now your user equipment is there, and your data network, external data network is there, and your PDU session is created. Okay. So once your PDU session is created, inside that, based on the customer needs, your QoS file will be created. Okay, so this is, say for an example, QoS 1, 2, 3, 4, 5, 6, 7. So 7 QoS will be created inside this video. Okay, so what comes when it comes to 4G? What will happen here?
Only one.
Only one QoS session will be created. Okay, and that also is for guaranteed bit rate. Right? Which are all services use guaranteed bit rate? Your voice call, your live video streaming, okay, that will come under your guaranteed bit rate. So that type of data which is there in the 4G, but in case of 5G, okay, so it is different from your GBR and non-GBR. Like, say for example, I can use 3 as GBR and 4 as non-GBR. Right? You have 7 QoS and 3 will be allotted for GBR and 4 will be allotted for non-GBR. So that kind of customization I can done in 5G, but this is not done in 4G. Able to understand this, right? So that is what QoS flows can be established and removed on the basis of QoS requirement of the user plane traffic. Right? So user plane traffic, that means who will divert the traffic, which network element. Who created this? UPF created. Okay, whenever traffic flows comes, okay, who will do the adjustment? So UPF will do the adjustment. Correct? UPF has created this PDU session. So UPF has the right to do the customization. So customization means, suppose if the user needs only QoS flow 1. Okay, so if QoS flow 1 is what? What is your QoS flow 1? Your QoS flow 1, which comes under your guarantee. Okay, so UPF will allow this QoS flow 1 to transmit from your user equipment to the data network. Okay, so where the instruction which comes from to the UPF, who will give the instruction for network slicing here? I want QoS 1 to flow, right? So who gives the instruction? Where this UPF will receive the instruction? Yes. From SMF, then SMF to the hierarchy. PCF where they will get the instruction. Who will give the instruction to PCF? Because this will come under network slicing. You are slicing your network based on the customer needs. Who gave the instruction? One network element which is used for network selection. NSSF will give the instruction to PCF. What type of instruction? Okay, the user is verified. Okay, now you can create a slice based on the customer needs. That instruction given to PCF. So PCF will check what type of policy we can do. What type of policy means whether this person is enabled for QoS flow 1 or 2 or 3. Once it is verified, this instruction is given to the next. Who is the next? SMF. Okay, so SMF will instruct the UPF. Okay, everything verified. You just create a tunnel. Tunnel means your PDU session for your data flow for this particular user. Okay, and what type of QoS flow that will be given to UPF. So UPF will decide, will implement this QoS 1 from user 1 to your data. So that type of you are arcing from control plane architecture to the right. Okay. Fine. This is one best example. Okay, how your QoS works. Right? Okay. So you know what is UE, user equipment, G-Node B, and here you can see here which core network we are focusing on. Only UPF. Why? This happened once your connection is established, that is your initial registration is established. Correct? Then we are moving to the user plane. So this core part which comes under your user plane. Correct? Okay. So UE, G-Node B and UPF is your user plane function. Okay. So first we will discuss about this. Next, I told you right, this yellow is your PDU system. This yellow. We're able to view this yellow color. Okay. So inside this PDU session, you have data barriers. I told you right, data barriers which is used to carry your data. Right. So which is your data barriers? This purple color and this orange color. Okay, I'll tell you. First, you have to understand what is what. Okay. So you have how many data barriers? Purple color 1 and green color 2. So you have 2 data barriers. Correct. And next, from G-Node B to UPF, okay, you will have a GTP channel. Okay, GTP channel which is nothing but GRES tunneling unit. I'll tell you. Okay, just understand this is your GTP channel. You define your user plane. Okay, right. So what are the things which is present between your UE and G-Node B? First your PDU session is created. This PDU session which is common to UE to G-Node B and G-Node B to UPF. Correct? So this is common to all three. And next, inside this PDU session, what was created?
Data bed.
How many data beds?
Yeah,
2 data beds is created. One is represented as purple color, another one is orange color. Between which and which? user equipment and G-Node. Correct? And between G-Node and UPF, which is created? Which tunnel is created? GDP tunnel. Correct? Both are same only. Your data bearer and your GDP tunnel both are same only. But what happened is UE and G-Node uses data bearer, and between your G-Node and UPF which uses your GDP tunnel. But these data bearer and GDP tunnel will do the same process of transferring your viewers from your user equipment to UPF. Right? So both which is used to carry your data, that is you are passing your data from your user equipment to the UPF. But what the main difference is, UE G-Node uses data bearer and G-Node UPF uses your GDP tunnel. Right? Now, how many viewers flow which is given here? 3 viewers. Right? Can you tell me why they are giving viewers flow 1 and 2 in this data bearer and this flow 3 which is in different data bearer?
Same requirement from the user. Same request they would have asked.
That is fine. Same correct. Same correct terms. Correct. Here we can call it as same QS flow 1, QS flow 2. These both will consider same GBR.
Okay.
Not same GBR, GBR. So QS flow 1 and 2 will consider GBR. This flow 3 will consider non-GBR. Correct? So inside the data bearer, I can create more number of QS flow, but inside the data bearer, I can create QS flow 1, 2, 3, 4, 5, 6, 7. I can create 7, but it depends. It will come under GBR or non-GBR. Okay, so I gave only one example. What is that example for which comes under GBR?
Live session.
Voice, live, okay, everything will come under GBR. So whenever you are serving data, that will come under your non-GBR. Right? So what happened is, whenever this data bearer will hold the same different viewers which comes under the same GBR. Okay, so say for example, this QS flow 1 is for voice one, and this is for live video stream. But what happened? These two comes under which one? GBR. Correct. So that I can create a video session, that is QS flow session inside the single data bearer. Right. But this QS flow is nothing but your non-GBR, so that a second data bearer, this comes under the second data bearer. Right. So say for example, if it is voice and your live video streaming, another which comes under GBR. I'll show what is that 1, 2 and 3 GBR. Okay, which is which 2, yes, 1 is for what, 2 is for what, 3 is for what. Okay, so if I give 1, 2, 3, 4, 5, this all 5 GBR will come, this all 5 QS flow will come under same GBR. So I can create 5 QS flows which is within this data pair, single data pair. This comes under, when it comes under GBR. Right. Okay. But you can see here, what about this GDP tunnel system? You have only one GDP tunnel, either it is from GBR or it is from non-GBR. Doesn't matter, you will have only one. What is this? GDP system. Correct? Okay, so this is the way your data will be transmitted from your UE to UPF, then your external network is received, external data network. Right? Are you able to understand? So this is nothing but your air interface that we have studied in architecture. Correct? Which architecture? Service based this one. Reference point.
Service.
Entry into air interfaces there means this will come under reference point architecture. Okay, but in case of service based architecture means you are using API to contact. Application programming interface to contact between different network networks. Right? Able to understand up to this? Okay. Every point is okay. So video session I have told will not be easy. Now this video session, okay, now come to this point. one user can have only one video session. Right? One user can have only one video session. Okay. Within this video session, you have number of data beds. Within the number of data beds, you have number of viewers close to it. Okay. Whenever a user wants to connect an external network, only one video session will be created as allotted for this user. Right? Say for example, this user equipment will be allotted only this video session. Within that video session, you have two data beds. Within the data beds, you have number of viewers close to it. Okay. So don't have the doubts of either I can have two video sessions to contact. Nothing. Only one video session will be there, which is allotted for viewers. Right? Everybody understand? Okay. Like you can start, you see this like biology point of view. Okay. You have a tissue, you have a skin, some muscle inside that, nerves and tissue, everything will be there, right? So likewise, this is your video. Video is the main. Okay, then you know that you have different things. So that is your data where you have those things. Right? Now, so we have discussed, right? So GBR, non-GBR. Right? Yes. Full form is guaranteed bit rate, non-guaranteed. Okay. So once I finish this session, I'll tell you what are the topics which is involved for 60 research topics. Right? So that you can people work on it and come with a solution. Okay. So next bit rate is the name itself which is given, guaranteed bit rate. So your bit rate is guaranteed, here it is not guaranteed. And next, resource reservation usually requires dedicated controlled resources shared based on network conditions. So this is what I have told, right? Your call or your live video conferencing, audio conferencing won't get disrupted. That requires your GPR. Okay. So this is based on the services. Like if I want to go for searching the Google now, this non-GPR ones. Okay. Next, real-time application, generally data applications. Right. So delay sensitivity is usually high, usually low. Correct. Then example is VONR, voice, real-time video, web browsing, email, downloads. These are all comes under non-GPR. Why? Because when I go for web searching or I go typing mail, when I download something, that time only I need this bandwidth. Correct. So that time your non-GPR is allowed. Okay. But GPR, in order to maintain a constant data rate, we are going for GPR. So the final one is typical 5QI. What is this 5QI?
Quality identifier.
5G quality identifier. What this identifier will do?
Identify what?
Identifier identifies what type of QoS. Okay, it is 1, 2, or 3, 4, and 5. Okay, so GPR you have 1, 2, 3, 4, and 5. Okay, and here non-GPR 6, 7, 8, 9, etc. Okay, now we are going to see what type of services this one delivers, what type of services this two delivers, 3 delivers. Right? So GPR means it is restricted 1 to 5, non-GPR means it is 6 to 9, then beyond. So why they are putting 9 here etc. means, so whenever a new research comes, that will be added 10, 11, 12 items. So that they are given. Okay, whenever the new research comes, that should be restricted within 5. That is called GPR. Okay, and 6 to etc. comes under non-GPR. Right? Right. Okay, so that is what? What is one? One is for this one. Okay, this one is for voice. So this will come under GPR. Right? And 2 is for video GPR. Okay, and 3 is for network. It's not 3 actually, it's 6. This is 6. Mistake here for this. 3. Because if it is 3 means it will come under GPR. Correct? So it is 6. That is equivalent data, it is not means is this Q of I tells the 5G network how a particular packet flow should receive into a string. Okay, so I gave one example, right? So you know what is GBR? So we have discussed a lot. Okay, so guaranteed bit rate. Your example, what is your example here? What is VONR voice call? What is VONR?
New radio.
Now we are using 4G network. So you can see your network voice over LD. VOLD. What is VOLD?
Fourth generation.
With the help of internet connection, we can make a call. Right? So without internet, you cannot make a call. So if your data shows, that is your network shows VOLD means you can connect via internet also. The call can be connected via internet also. Right? So VONR means
5G.
voice over new radio. That is your 5G. That is what? Okay. Voice call, real time gaming, industrial control. Okay. So why this will comes under GBR? Can anyone tell me? Why this application will comes under GBR? That's what I gave an example, right? So these all need a guaranteed bit rate to handle the data for the entire system. If there is any change in the guaranteed bit rate, automatically your call gets dropped or any application real-time gaming will goes down and your industrial control which is connected via IoT will goes down. Right? Okay. So non-GPR, no. So web browsing, email, downloads and social media, these are all comes under non-GPR. Now you can able to differentiate what is GPR and non-GPR. Correct? And few examples of QoS, voice, video and internet which is given. Able to understand up to this part. So GPR, okay. GPR example voice over NR. The voice call requires normally voice call your data rate is very less, right? Okay, it is in the form of data rate is kbps. Okay, 64 kbps and GPR QoS flow and non-GPR web browsing. Okay, so you may get 10 kbps, 5 kbps, and degrees of depends on the traffic 2 kbps. Okay, so you can see here, if I use this voice call, you should get a guaranteed bit rate of 64 kbps and during the entire session. Entire session means I'm just calling to another person. A person at the other end who is receiving my call. The conversation takes place for another 10 seconds. Till the 10 seconds, your data rate will be 64 kbps. Right? But here, when it comes to non-GPRs, non-GPR, okay, when I'm going for browsing, sometimes, okay, gives a 10 kbps. Okay, then if I go for some other application, your data rate reduces to 5 kbps, and I go for some other applications, your data rate reduces to 2 kbps. So this is not guaranteed. The data rate varies, so this will come under non-GPR. Right? Now, two-step mapping on QoS. Right? Okay. Now you understand. Okay. So what is with this? You can able to understand what is QoS flow 1. Okay. And what was the what is DRB? Data. Radio. Barrel. That is what you are seeing here. This one. Radio barrel. Okay. And what is this? This is QoS flow. And what is this? GTB. Okay. Now come to this. Right. So this is from downlink. Okay. So downlink is from where you are? Downlink. From external network, data network to your user area. Correct? So this flow is from your external data network, okay, to your user area. This is your user area. Correct? Your call flow from external to user area. Now you see this picture, okay. So this is IP flow, your data flow. Okay. So first is your WhatsApp video, your Skype video, your YouTube stream. Correct? So this is your internet video. Your video session will be created. Correct? Okay. With that video session, your services will be customized. Right? Now you see here WhatsApp, Skype, YouTube stream, which goes inside this UPF. Okay, just imagine this is downlink. Downlink is from external network. So external network is your public network. Okay, your public network. Suppose if I want to use WhatsApp. Correct. So this WhatsApp service, where it goes? It goes to UPF. Okay, UPF will have SDF. This is your traffic template. Just leave this. Okay. So what this will do is actually this will filter the signal which is coming from the external. How it will filter? How it will filter? Based on the QoS flows. Right. Now you see this picture and tell me. You see this picture and tell me. WhatsApp video, Skype video, YouTube stream. Correct? This is given to the filter. This SDF is nothing but your filter. After that, what will happen here? This Skype video and WhatsApp video, which comes under which one? QoS 2. Correct? Are you able to understand here? So this is from external network, and when it comes to this UPF, what is the function of UPF will do here? It will create a custom video session. Correct? With this video session, it will find which services belongs to which QoS. That type of function which is done by UPF. Correct? Now you see this WhatsApp and Skype which is clubbed together and which is given to this QoS. Correct? Okay. Now, and this best effort, this will come under QoS flow 1. Best effort is whatever they mean. Best effort means your voice call. Correct? So your voice call, your WhatsApp video, Skype video, then YouTube will be given at different QoS, and that is defined as QoS flow 3. Right now, so the UPF function of here is, which is used to filter out the type of services belongs to which QoS. That is the function of UPF. How this UPF will do? By using this template, that is SDF template. Right? Service data flow template. This is okay. SDF means service data flow template. Now, come to this G-Node part. And see here, your another Netflix stream, which is given a QoS 4, and voice, which is given QoS 5, and video, which is given QoS 6. Right? So these two services are clubbed together to a single QoS. Okay, so this is done between your UPF and G-Node. Correct? Okay. Again, what will happen? Another filtration will be done. Where it will be done? In G-Node B. Okay, using SDAP, Service Data Adaptation Protocol. So this is one protocol. This is one of the protocol used between which and which? Used in G-Node B. So what is the function of this will do? See this picture. What is the function of SDAP protocol? Service Data Adaptation Protocol.
Whether they all come under guaranteed or not.
Yes. It will check, okay, all the QoS flows, and it will tell that which all comes under GVR, which all comes under non-GVR. Based on that, it will be given to the data bearer. Data, you have seen in the first slide, right? What is where the data bearer will be present? Between which and which?
Between user equipment and G-Node.
Between G-Node B and your user equipment. Correct? So, your data bearer contains which type of services? Which includes which type of services inside?
The GVR is not.
Either it is GVR means all QoS flows will club together will be placed in this data bearer. If it is not GVR means all the services will be clubbed together based on the data bearer. But it is different. Say for an example, one GPR, one is non-GPR, means it will create two data bearers and that the traffic will be given accordingly. Right? Now you can see here, this flow 2 and flow 3, this YouTube video, Skype video, WhatsApp video, all together will come under GBR data rate. So this will be given direct non-GBR system. Okay, so these are all clubbed together and will be given to DRB. Correct? So how many data pairs is created here? One is for best effort, and second 2, 3, 4, 5. Correct? So this implies these together will come under the GBRs. GBR or not GBR? Okay. So this will be given to one data bearer. Then finally, what this SDAP will do? This SDAP, same we have done a G0T, right? And this is user equipment. What this SDAP will do here? Same. This SDAP which is used to filter out. The function of SDAP which is used to filter out particular services, right? So when it reaches the user equipment, it will check what type of services the user is requested. Okay, so that service will be given to you. Okay, so this service, it will find in which data bearer this service is there. The user equipment will find. Suppose if I want WhatsApp, YouTube video, and what more Skype. Okay, so what this user will do is it will choose DRB. Able to understand? Like this way, your IP will flow from your external network to your user network. Vice versa, if you go from uplink, what it will do? Same, like this it will create. The flow will be like this. So what it will do? First it will create user equipment, between user equipment and this G0P, what it will create first?
Data bearer.
Data bearer. Okay, once data bearer is created, inside this data bearer what it will do?
Which one?
It will split into GBR and non-GBR data. If it is the same GBR, if it is the service is the same GBR, it will give one data bearer. If it is non-GBR, it will give another data bearer. Then when it moves over here, what will happen? UPF.
Based on what service?
Based on services, this is splitted. Okay. So here is your external network. So what tunnel will be used here? Between this and this, G0T GTP tunnel. Okay. So with this tunnel, whatever the service which is coming inside, it will goes accordingly and it reaches the external. So external network is available here. Suppose if I want to go for WhatsApp or Netflix voice video, like this, it will move from uplink to from user equipment to your external network. Is your the picture which is shown is downlink this class. Able to understand here? Right? Likewise, the same. Okay. So in real time, if you want the access to your YouTube, your Netflix means this process has to take place within a one millisecond. Not 1 millisecond. Right? So that fast, your data will be transmitted via pass through these G0Ts and reaches are. Right? Okay. This is what they are given. Okay. And how will you do this? When you go to this 5G lab, okay. So you have to give some protocol name to see where the packet is. Correct? So for that we are using NAS filter as a command over. Okay. So if it is a NAS filter, from where to where? So this is what actually this GW. Just read this. It's not GW. This is your UPF. This is your G0P. Here it is given G0P. It is G0P because it is 5G. Here it is your user equipment. Right. So what does this actually?
That tunnel.
Okay, that is from WhatsApp, your YouTube, this thing, which is flowing inside. Okay, so what is this? This is your SDF template. Correct? From this SDF template, it is splitted based on the QoS. Correct? Then it goes to G-Node B. Correct? From the G-Node B, it goes via radio bearer. Okay, and it will reach the user. So user equipment also you have SDF template. Correct? This is what they have given in this tutorial database. Right? Now you can see, if I want to get the data from user equipment to G-Node B, okay, so what I have to do is, I have to use this AS filter protocol to see what is happening between UE and G-Node B. Correct? So if you go to that file, you have to use this Linux command I said, right? So by using, we can do this in Wireshark. Okay, because if you want to capture a particular protocol, I can use Wireshark. Right? So if I use Wireshark, if I give NAS, suppose if I am typing this NAS protocol means, what it will display? NAS protocol, which is used to link between utilities. Your user equipment QoS flow data and your G-Node B equipment QoS flow of data. That type of information I can see in the Wireshark whenever I type AS filters in the Wireshark. See, Wireshark which is used to capture the network. Okay, if I give some protocol, with that protocol I can able to see what is transmitted between this and this network. Right? So when I give this AS filters in the Wireshark, I can able to see what is happening inside this UE, and also I can see what is happening inside this G-Node B, how your queue is flow, how many data packets is flow, and what is the QoS flow ID, everything we can check in real time, and I give this AS protocol. Right. Same as when I give NAS filters. When I give this NAS filters, I can check between which bits. UPF and your user equipment QoS flow I can check. Okay, so in Wireshark, when I type this NAS filter, you can check the connection between your UPF QoS flow data. What QoS will be there? That is also mentioned here. Either this QoS flow 1, or 2, or 3, or 0, everything will be displayed here. Okay, so like this, I can check in the UPF section, sorry, UE section also. And I will click this NAS. You able to understand? Right. See, till now we have seen theoretically, correct? So when you go for practically, when we use this Wireshark, you can see what are the present by using this. Right? I got this. This part you know, correct? Control plane. And this part you know, user plane. And this creating session, you know how it is created. Right? Now come to the next one. So with this diagram, can anyone able to identify what is where they are given these things? Now, I told you right, how many PDF sessions which is created for the user?
One.
For single user.
One.
For single user, it can create only one PDF session. Correct? So how many users they have given here? UE1, that is user equipment 1, user equipment 2, UE3. Right. Now, you see here, what is this? I told you, right? This is, inside this, what is it? This blue color is what?
Parent.
Radio data pair. Okay. And this is one data pair. Right? And what is this yellow? GDU. And now, you can see, and this SDF and this SDF, you can create two QoS. Why?
Same guaranteed.
This comes under GDR QoS flow. So that QoS flow 1 and 2 I can create within a single data. First of all. And this comes under non-GDR, so I have to create another QoS flow in another data pair. Correct? But as I said, you have only one GPU running you. Okay, next. The same. If UE2 wants to use a non-GBR QoS flow, okay, so what will happen? What is this? UE2 and UE3. What is common here? Just see it.
Data bus.
Which is common here?
Data bus.
Data ERP is common here. Okay. So why it is common here?
Both requested same not GBR.
Both are using not GBR. Correct. So what is that meaning? Two or more users can use the same data bearer. Okay, if they have same QoS. Able to understand? Correct? Yeah? So that is why they are given UE1, UE2, UE3. Okay, if you have same data flow, same non-GBR services, one data bearer which is created for different users. Right? Now you see here, but what happened to this GDP tunnel unit?
Different.
Your GDP tunnel unit is different for different users. Correct? This is the main point. Your data bearer is common, but your GDP is different. Your data bearer is between which and which? Between your user equipment and your base station. Correct? But your GDP is between your base station and core network. Sorry, your UP. Correct? Right? So this is what they have mentioned here. Okay. So two or more users can use one data bearer at a time, but your GDP will be different. Right? They will understand this picture. And as I told you, right? So one user can create how many PD sessions?
One PD.
So that is also mentioned here. User 1, okay, so one PD session. UE1 PD session. Next, user 2, UE2 PD session. And UE3, UE3 PD session. But they can share data better. Okay, but they cannot share this GDP. So that means from UE to base station,
Same.
you can use same resources. From base station to your final, your UPF, they cannot use the same resource. That is it. You able to understand? Right, so this is what we have discussed. Stop it.